everyone, and welcome back to another video. We're going to be covering chemistry topics, but it's basically just going to be a review of some previous chemistry questions and a test that was taken. So I'm just going to show you how to answer them and what the right answers are. The first question is asking us to construct a mathematical representation to determine the total number of molecules contained in a 0.50 mole of oxygen at STP. So the main things that we want to highlight is to determine the total number of molecules contained in a 0.50 mole. The reason why this is important because it demonstrates us what the conversion has to be. Since it's asking us to find the number of molecules, we need to go from moles to molecules, right? So the equation or the formula that we use to find the number of molecules, atoms, or particles is, I'm just going to write it down. So the number of molecules, particles, or atoms is equal to 6.02 times 10 to the power 23, which is also Avogadro's constant, times the number of moles that we have. Number of moles. Since this constant right here never changes, all we need is to find a substitute for the number of moles. And this value is already given to us in the question, which says 0.50 mole. So all we really have to do is input this value in the calculator, which would be 6.02 times 10 to the power of 23 times 0.5. And your answer should be 3.0 times 10 to the power of 23. The next problem is asking us to calculate the GFM or gram formula mass of CuSO4 plus 5H2O. So this symbol right here means addition in chemistry. Don't get it confused with the other math classes, where you could use this dot as multiplication. In chemistry, it just means addition. So again, the GFM or gram formula mass is just the total average atomic mass of a certain substance. So first we have to calculate the GFM of this here and this here. So let's start off with CuS and O4. So we have one copper atom, one sulfur atom, and we have 4 oxygen atoms. So we can write this down. So we have Cu, we have S, and we have O. So when we look at our reference table, we can see that the average atomic mass of copper is 63.55. And since we only have one, we can just do times 1, but it's really just the same thing. So it's still going to be 63.55. And then the average atomic mass of sulfur is 32.06. And again, we only have one sulfur atom, so we just multiply it by 1. It's still going to be the same thing. And then the average atomic mass of oxygen is 16. And since we have 4 oxygen atoms, we're going to multiply it by 4, and we're going to get 64. All of this is in grams, by the way, because it's the average atomic mass. So our next step is we have to add all of these values, and we're going to get a sum of 159.61 grams of CuSO4, right? That's just one side. We still have to figure out the other side. So we can write down hydrogen, and we can write down oxygen, because those are the only atoms that we have present on this side. Pay attention. We have a coefficient of 5, meaning we have to distribute and multiply this coefficient to the subscripts of these atoms. So we distribute the 5 to the 2 hydrogen, meaning we have to do 5 times 2, meaning we have 10 hydrogen atoms. And then we distribute this 5 to the 1 oxygen atom, meaning we have 5 oxygen atoms. So the average atomic mass of hydrogen is 1.01, but since we distributed the 5 to the 2, we have 10 of these hydrogen atoms, so we're doing 10 times 1.01, which is going to be 10.1. Then for oxygen, the average atomic mass of oxygen is 16, but since we distributed the coefficient of 5 to this 1 oxygen, now we have 5 oxygen atoms, so we have to do 16 times 5, and we're going to get 80. Now we add these again, and we're going to get 90.1 grams, right, of H2O, I guess. Or I don't know if it would be 5H2O. What matters are these values, the 90.1 and the 159.61. Now here's when we come back to the addition symbol. We add these two values together. So we do 159.61 grams plus 90.1 grams. And we're going to end up with around 250 grams, which is the GFM. Our next problem is asking us to calculate the quantity of moles contained in 13.7 liters of helium at STP. So the first thing you want to think about when you see the word STP is 22.4 liters. When you look at your chemistry reference table, in the back page, you have a table that shows mathematical relationships. And you can see that 1 mole is equal to 22.4 liters ideal gas at STP. So if you want to write that down, 1 mole is equal to 22.4 liters, which is also an ideal gas at STP. Knowing this, it'll help you write your conversion factor, because what this question is asking is to find the number of moles given the amount of liters that you have. So what we want to convert to is we want to convert from liters to moles. And the equation the formula that we use for that, the given volume in liters divided by 22.4 liters. And that's going to give us the number of moles. So our given volume is already told to us in the prompt or in the question, which is 13.7 liters. So we can write that down right away. And we just use this constant, which is 22.4 liters. So all we have to do is divide, and our answer is going to be 0.6 moles. The reason why this also works is because the liters cancel out. So we're just left with moles. You can also do the conversion factor where you write the given amount of liters or the given volume, which is 13.7 liters, times 1 mole over 22.4 liters. The reason why we can do this is because we can cancel out the liters, right? And then we just cross multiply. So we do 13.7 times 1, which is 13.7, and then we divide it by 22.4. This is just a way of doing dimensional analysis, but it gives you the same thing. So your answer would be 0.6 moles. And that's if you round it to the nearest tenth. Now in this next problem, it's asking us to calculate the total number of atoms contained in 80 grams of neon. So similarly to the first question, it's asking us to find the number of atoms. And if you remember the formula, in order to find the number of atoms, molecules, or particles, we have to do 6.02 times 10 to the power 23 times the number of moles. And in this problem, we don't have any moles given to us, but we do have grams. And these grams we can convert to moles. So in order to find the amount of moles given the grams that we have to do number of moles is equal to given mass over the GFM in grams, right? So our given mass is already set in the question, which is 80 grams, right? But now we have to find the GFM. And the GFM of what exactly? Neon. And since there's only one neon atom specified, we just look at the average atomic mass of neon, and the average atomic mass of neon is 20.18 grams. So now we can cancel out the grams, and we just do 80 divided by 20.18, and we're going to get around 4 moles of neon. Now that we know how many moles there are, we can finally substitute it into here. So now we just write 6.02 times 10 to the power of 23 times 4 moles. And we're going to get 2.4 times 10 to the power of 24 atoms. Sorry, this just looked like a 1. There you go. So this would be your answer. So in this next problem, it's asking us to calculate the total number of moles contained in 115 grams of C2H5OH. So our first step is to identify what we're converting to. So it's asking us to find the number of moles given how many grams we have. So our conversion factor is grams to moles. And we can do that because we know that the number of moles is equal to our given mass in grams over our GFM in grams. So we can use a variable for x, which represents the number of moles. Our given mass is 115 grams, as stated in the question. And then we need to find the GFM. We find the GFM through this right here. So according to this, we have 1 carbon atom, we have 6 hydrogen atoms, and we have 1 oxygen atom. So we have 1, 6, and 1. So according to this problem, we have carbon, we have hydrogen, and we have oxygen. But how much? Well, here the subscript of 2 shows us that we have 2 carbon atoms. Here we have hydrogen twice, right? And we have a subscript of 5, and we have a subscript of 1. So we sum it together and we have 6 hydrogen atoms. And then we have 1 singular oxygen atom, right? So now we just have to figure out their average atomic mass. Well, carbon has an average atomic mass of 12.01. So we do 2 times 12.01. We get 24.02. And then hydrogen has an average atomic mass of 1.01. So we do 1.01 times 6. And we get 6.06. And then oxygen has an average atomic mass of 16. So we do 1 times 16 and we get 16. So now we add all of these together and we're going to get a sum of around 46.08 grams approximately. And now we can substitute that as our GFM. So we can put 46.08 grams. The grams cancel out and we just do 115 divided by 46.08. And we're going to get that X is equal to 2.5 mole of neon. Our second to last problem is asking us to calculate how many moles of H2O are needed to exactly react with 2.0 moles of calcium. So there are 2 ways to do this. I will show you the first method, which is the mole-to-mole ratio method. So mole-to-mole ratio. And the other method will be dimensional analysis. So the 2 main moles that we're looking at is water and calcium. So we can write down H2O and we can write down calcium. So when we're looking at this chemical equation, we can see that we have 1 calcium mole and we have 2 moles of water, or H2O. So that would be our ratio. For every 2 water moles, we have 1 calcium mole. But now it's asking how many moles of water would be needed to react with 2 moles of calcium. So now we can write a new ratio where there's 2 calcium, but we don't know how many moles of water. So we need to think about this logically. How do I get from 1 to 2? Well, I can multiply by 2. And whatever I do on one side, I have to do to the other side. So I do 2 times 2, and I'm going to get 4. So that means I'm going to need 4 moles of H2O to react with exactly 2 moles of calcium. And for the next method, I need to multiply my given amount of moles times the mole of unknown divided by the mole of known. So how many moles am I given? Well, in the problem, it says I'm given 2 moles of calcium. So I can write down 2 Ca. And I'm multiplying it by mole of unknown over mole of known. Well, how many known moles of calcium do I have according to the chemical equation? Well, I have 1. So I write down 1 Ca. And then how many moles of unknown? Well, my unknown value is H2O. And according to the chemical equation, I have 2 H2Os here. So I write that down, 2 H2O. So now I can eliminate or cancel out calcium and I can cross multiply. I can do 2 times 2, which is 4, divided by 1 here. And I'm just going to get 4 moles of H2O, which is the same exact thing as the method here. Now for the last question. So the last question says a popular smartphone has a mass of 172 grams and requires let me just annotate this, requires 10.32 grams of aluminum to manufacture. Equation 1 represents a model of the overall chemical process used to obtain aluminum from the purifier aluminum oxide. Construct a mathematical representation and calculate the number of grams of aluminum oxide required to produce the aluminum necessary to manufacture 1 smartphone. So, this is some information that we're given, and this is what we have to find. We have to figure out grams of aluminum oxide, like that. So, we're given grams of aluminum, but they want us to end in grams of aluminum oxide. which are 2 different moles. So we already have to start thinking about what kind of conversions we can do. Because if we're switching from aluminum to aluminum oxide, we have to have a multimole ratio somewhere, multimole conversion. So here's the process that we would do. Our first step would be to convert the grams of aluminum into moles, right? Because then once we know the moles, we can convert those aluminum moles into aluminum oxide moles. Oops. L2O3 moles, right? And once we know how many moles are in aluminum oxide, we can then convert it back to grams of aluminum oxide. So Al2O3 mole to L2O3 grams. That way, we successfully convert the grams of aluminum to grams of aluminum oxide. So we need to do 3 different conversions. So let's do our first step. How do we convert grams to moles? Well, we know that the number of moles is equal to the given mass in grams divided by the GFM. So we can use a variable to represent the number of moles. Our given mass in this problem is 10.32 grams of aluminum. And the GFM, how do we calculate that? Well, when we look at our reference table, we can see that the average atomic mass of aluminum would be 26.98 grams, right? So the grams cancel out. So you're going to put 10.32 divided by 26.98 in your calculator, and you're going to get around 0.38 moles, right? So these are specifically moles of aluminum. We have step 1 done. We've converted the grams of aluminum into the moles of aluminum. So that was step 1. Now step 2, let me just label this. This is 1, 2. Now we have to convert these moles of aluminum into moles of aluminum oxide. So how we do that is we use another formula, which is the given number of moles times the mole of our unknown value over the mole of our known value or given value. So in this case, our given number of moles would be the amount of moles of aluminum that we identified in step 1. So we would write down 0.38 moles of aluminum, right? Times, so what mole are we trying to convert this to? Aluminum oxide. And how many do we have? Well, when we look at equation 1, we can see that we have 2 aluminum oxides. So we would input 2L subscript 2 O3 on the numerator. And on the denominator, how many aluminums do we have according to this equation here? We have 4. That's how much is given to us. So that's how much we know. So we have 4 Al. Now we can do dimensional analysis. We can eliminate the ALs because they cancel each other out, and then we cross multiply. So we do 0.38 times 2. You'll get around 0.65, I'll say, divided by 4, and you'll get around 0.19 moles of aluminum oxide, right? So now we successfully did step 2. Now we have to move on to step 3, our last step. Now we have to convert these moles of aluminum oxide into grams of aluminum oxide. So we basically do the reverse. All we have to do is we have to multiply the number of our given moles times the GFM over 1 mole. And the reason we do this is because once we cancel out the moles, we'll be able to then convert it and revert back to grams. So the given amount of moles that we have comes from step 2, which is 0.19. So 0.19 times, now in the numerator we have to write down the GFM. And the GFM of what specifically? The GFM of aluminum oxide. So we have to take out L2O3. So 2, then O3. So we have 2 aluminums. So that means we're doing 2 times 26.98, the average atomic mass. And then we have 3 oxygen atoms, and the average atomic mass of oxygen would be 16. So then when we multiply it, we get 2 times 26.98 is equal to 53.96, and then 3 times 16, and then 3 times 16 would give you 48. And when you add them together, you're going to get 101.96 as your GFM in grams. So then you write down 101.96 grams over 1 mole, right? So then the moles, they cancel out, and you do 0.19 times 101.96 divided by 1. So we're basically just multiplying this, and we're going to get an answer of 9.4 grams of aluminum oxide. However, the only reason why I got 19.4 is because I rounded too early. So here's where you have to be careful. Whenever you're multiplying or adding these values, you have to make sure that you round them at the very end. So your actual answer would be 19.5 grams of aluminum oxide. This is if you round at the very end. So whenever you're using the calculator, try your best not to round any values until the end. So just keep all the values the same. Don't round any decimal places. Your actual answer would be 19.5.